Yep.
Okay, good afternoon. So, it's not noon yet. Anyway. So I hope that you didn't waste your time yesterday and you watched that video. So I want to continue that. So in that video, if you remember, we talked about the graph of sine and cosine functions. Okay, and then today the idea is that we want to see a little bit more about more generic sine and cosine functions. In other words, I want to understand qualitatively using the transformations that I'm going to talk about. We want to know about the graph of this function, okay, in which a, b, c, and d are constants. And I want to know, of course, something similar for this function. So I would say that these are general sine and cosine functions. Yes? So if I want to, you see here in the original sine function, a is chosen to be 1, b is chosen to be 1, c and d are chosen to be 0. Yes? And this will give me that one. And for the same choices of a, b, c, and d, this will give me that one. But I want to understand from qualitative point of view and some rules how the graph of this function for different values of a, b, c, and d is related to the graph of this function, and the same question for the graph of this one. I don't know, for some reason the book has chosen to talk only about sine and cosine functions, but these transformations that I want to talk about are completely generic. So I don't think it will hurt if we understand them for every function and then apply them for this case as well. Okay? So, yes?
Does this always assume we're using radians, by the way?
No, you can choose if you want, you can put a degree there, but you have to be consistent, yes? Okay, so let us try to understand some transformation. Now, let us forget about everything. Of course, my goal is to come to this, but forget about this momentarily. And let us assume that someone has drawn the graph of any function like this. So you don't have the rule of the function, you have the graph of the function in front of you. And someone tells you that, okay, in that function, what happens to the graph if I do this transformation? If I change x in the graph in the function everywhere to minus x, how the graph of the new generated function relates itself to the graph of the original function? Yes? So these kinds of questions we want to discuss today. Of course, I will ask your intuition about that as well. So one transformation is changing x to minus x. Another transformation is asking the same question for y. What happens if I change y to minus y? Another question that I can ask is what happens if I change x to x plus a constant? Okay, what happens if I do the same transformation for y plus a constant? And then what happens if I change x to a number k multiplied by x? And what happens to the graph if I do this one? Okay. But for the y ones, I prefer to do it on the right side rather than this. Because, for example, let us take this simple scenario. If y equals to f of x is given, and I change y to minus y, what happens? It becomes minus y equals to f of x, yes? But this is not the standard way of writing a function. Because if I ask you to write a function, you prefer to put y always here and put everything else on the right-hand side. So this is why when I say y to minus y, it means the function f of x is being multiplied by a minus sign. Yes? Okay. So when I say y to minus y, practically it means if I take the function and multiply it by an overall minus sign, what will happen to the graph? Or for example, this case, if I replace y with y plus a, this is not a good way of writing a function because we have used to put y on the left and everything on the right. So this means that I am moving this to the other side, so it becomes f of x minus a. So in principle, it means that what will be the effect of subtracting a number from a function? Something like that. Okay, but you understand what I mean. Okay, so for example, in this case, if I replace it with kx equals to f of x, in principle, it means that multiplying the whole function by a constant 1 over k. Okay? Okay, so let us try to understand that. Let us ask your intuition about this. Is the question clear? So for example, I give you the graph of this function. Let me choose something simple that we can understand. I will of course use extensively GeoGebra this time. So if someone gives you the graph of this function, my question is that go to this function. I am talking about the first transformation. Okay, so I go to my function. I replace every appearance of x with minus x. Then I will have minus x to the power of 2 minus 2 minus x. Yes? I hope that you agree with me. This is a function. This is another function. So for example, if you simplify it in your head, it becomes positive x squared, positive 2x. And of course, this function is different from that function. Okay? My question is that if I give you the graph of this function without redrawing things again to get this, how can you understand the graph of this new one from the old? Yeah, is the question clear? Yes or no? Yes? Okay. What is your intuition before I tell you what happens? Yes?
For this graph,
Not for this graph. In general, if I go to my function, I see x's in some places, take them off all of them, and replace them with minus x, it becomes a new function. My question is that what do you think is the relation between the graph of this new function generated by replacing minus x for x and the original graph? There's a simple answer to it, and I want you to know that.
my intuition would be that it can depend, but maybe it can't.
No, it doesn't. So there's a very straightforward answer to this. It will be, do you want to say, Sergey? Was you pointing something? Yes?
Just go.
What happens? Flipped about
y-axis.
y-axis. Okay, that's the point. So I don't know if you want to write it down so that I want you to remember. The effect of transforming x to minus x is that the graph of the function will be flipped about the y-axis. But let us see why. I want to give you the reason, then I go a little bit faster for the next time. So let us try to understand that. So I would say that let us take alpha beta, a representative point on the graph of this function. Okay? So let me make it a little bit cleaner. So here, let us say that I assume that alpha and beta is any point you like on the graph of this function. My claim is that if you flip this about the x-axis, first of all, if you flip this about the y-axis, what are the coordinates now? Minus alpha and beta. My claim is that if alpha and beta is on this graph, minus alpha and beta will be on that graph. It is very simple to understand. Why? Because when I say alpha and beta is on this graph, what does it mean? It means that instead of y you put beta and instead of x you put alpha, this equality holds. So this is true. Why? Because I told you myself that alpha beta is on this graph. Now I want to prove that this point is on that graph. If I want to prove that, what I'm supposed to do, I am supposed to replace y with y coordinate. I am supposed to replace x with x coordinate and and prove that that equality is also true as well. Okay, so let us do that. I replace y with the y coordinate. I ask myself, is it true that Now replace x with the x coordinate. There is a minus sign here. There is a minus sign in the x coordinate of my point to the power of 2, minus 2, minus alpha. Is that right? I need to see if this is true or false. Is that clear? So this point is, I give you myself that this point is on this graph. I want to prove for you that its mirror image with respect to the y-axis will be on this new graph. In order to show that this is on this graph, I need to show that the coordinates of the point satisfies the equation of the function. Meaning that if I replace y with the y coordinate and x's with the x coordinate, this question mark is actually, the answer to this question mark is positively true. But do you think this is true or not? Yes or no? Yes. Why? Because if you do algebra here, what happens? Minus alpha is the same as alpha. Minus alpha is the same as alpha. Is this true? Yes, because I assume that this is true. So I did nothing. I tried to convince you that this is the case. So whenever you choose a point alpha and beta on this, definitely minus alpha and beta is on the other one. And so it means that because this line of proof works for every point, so it means that if you flip the graph of that one, it will be the graph of the new one. We can check using GeoGebra as well if you want to. At the end of the day, if you don't like the proofs and things like that, but you need to know what is the effect of this transformation. This is something that you need to do. No. Okay, so I will go to GeoGebra. So let us ask GeoGebra to draw the graph of the first one, which is x to the power of 2 minus 2x. So that will be the graph of the first one. But now let me draw the graph of the first one. The second one. I intentionally write it in that way so that you can understand that I am doing the transformation. Okay. So I am taking x's out. I am taking x's out and I am putting minus x instead of every appearance of x. And then to the power of 2. And then I go down minus 2 and then minus x. Intentionally, I type it in that form. So I don't know why GeoGebra doesn't change the color. So let me change the color myself. Okay, so let me change the color to, say, red. Okay, now you see G is the red one. F is the black one. Can you feel that the red one is the mirror image of the black one with respect to the y-axis? Yes? Because this branch that you see here of the black one, after being flipped about the y-axis, becomes this branch of the red one. And this branch of this part of the black one, after being flipped about the y-axis, becomes this part of the red one. So hopefully you agree with me that the red one is the flipped of the black one with respect to the y-axis. So yes, but that was also the proof. Okay, so if you don't mind, let us go here and do this one first, and then we can talk a little bit about y's later. Okay, so let us see what happens if I go to my function, replace every appearance of x with x plus or minus a constant. Okay, so let us just understand this from here. I want to ask your intuition about that first, and then we do it on GeoGebra. So my question is this. Again, let us consider the same function. Y is equal to x squared minus 2x. Let us say that I take x and replace it everywhere with x plus 2. Okay? So then what happens? Then my new function will be this function. So I am talking about all possible functions, not like the book. The book is only talking about sine and cosine functions. So you will see, of course, what happens. I already drew this using GeoGebra. I can put this in GeoGebra and see what happens. But I want to ask your intuition about it because I want you to understand what is going on rather than just memorizing this. Yes. So What will happen, do you think, here? If I increase every x by 2 units, what will happen to the graph of this function? So, Sergey, you are actually pointing me to some kind of shifting and translation, but in which direction and how much? Okay, so this is the intention. This is a little bit counterintuitive. So you said everything right, except that you said we go to the right. Yes, we have to go to the left. It's a little bit counterintuitive. I want you to understand this one as well. Okay, so my claim is this. My claim is that if alpha and beta, again as before, let us say that alpha and beta is on the graph of this function. What does it mean? It means beta squared is alpha squared, beta is alpha squared minus 2 alpha. Yes, this is for granted, true. I'm assuming that this is true because I'm assuming that this is on this graph. But look, Sergey's first intention was to say that we need to shift it 2 units to the right. If I shift these 2 units to the right, can you read the coordinates of this one for me? If I take the same point, just shift it parallel to the x-axis, 2 units to the right, what will be the coordinates? The beta coordinate, do you agree, will remain the same, but the alpha coordinate becomes what? Alpha plus 2. But alpha plus 2 and beta does not satisfy this question necessarily. Yes? Because if I replace x with alpha plus 2, then I am in trouble. It becomes alpha plus 2, which is alpha plus 4, minus 2 times alpha plus 4. But I cannot immediately grant that alpha plus 4 to power 2 minus 2 times alpha plus 4 is true, because what I know is true is this one. Is that right? So this is not a good transformation, even though intuitively people think that it should go to the right. But now let us say, so this is not working in general. But let us shift to the left. I go 2 units to the left. Read the coordinates for me, please. So what are the coordinates of this one, if that's 2 units again? Alpha minus 2 and beta. But do you agree that alpha minus 2 beta immediately satisfies this one? Why? Because if I replace x with alpha minus 2, there is a 2 that cancels that one, and I am left with alpha. So it becomes alpha squared, which is exactly this one, and that also becomes alpha. So this means that this is definitely satisfying this equation. So if I add a constant, if I add a positive constant to x, the effect will be a shift along the x-axis, but in the opposite direction. If I add something, it goes to left. If I subtract something, it goes to right. Yes? Is that right? So let us understand that using GeoGebra as well. So let us go back to GeoGebra. If you don't mind, let me take this off. We don't need it. And then what I do, I want to draw the graph of this new function after I replace x with x plus 2. So it becomes x plus 2 to the power of 2. And then I go down minus 2 times x plus 2, yes? So that is what it is. So, and if you don't mind, let me change the color. Okay, usually GeoGebra is always changing the color automatically, but when you need it, it doesn't work like that. I don't know why. Yes. Anyway, so let me change this one. Okay, so might be that's not a very good example because it is exactly the previous one. Okay, but I can motivate that. But at least I hope that you see that the red one is the new one, the black one is the old one. So what happens? You see the red one is the shifting of the black one 2 units, but to the left. Is that right? Yes, because this minus 2, after being shifted 2 units to the left, goes to 0. This point goes here. I don't know, this branch will be, this part will go here, this part will go there. And if you want, we can do a little bit better. So what can I do? I can write 1 y is equal to, instead of writing x plus 2, let me write x plus a. If I remember correctly, GeoGebra will provide a slider for it, yes? So to the power of 2, and then I go down minus 2 times the x plus a. As soon as I pressed enter, I think GeoGebra will provide a slider, yes. So it provides a slider that I can interchange. We can vary these parameter between minus 5 and 5 here. So if you don't mind, let me edit it a little bit so that it goes to from positive values for the time being, not get confused. So let us say that from 0 to 5. So my slider goes from 0 to 5. Of course, if this is 0, oh, what happened? Oh, so what? Yes, if this is 0, what happens then?
It overlaps the other graph.
Yes, you are right. Let me take the green one. So if this is 0, of course, you see this is a little bit thicker. It means that this is there. But now if I start moving it and increasing A, what is happening? You see it is not going to the right, it is going to the left. Yes? Something like that. So you can also see it the other way around. If you put it negative, it will go to the right. Okay. So any questions here?
It's just the opposite for minus A, right?
What?
For minus A, it's just going to go to the right instead.
Yes, yes. Not minus A, because A is a constant. It depends if A is itself positive or negative.
Yeah,
So if you add a positive number, it goes to the left. If you subtract the positive number, it goes to the right. Yes? But I want you to understand, I mean, if you forget, so this analysis, this thing that I'm trying to motivate you to understand, it shouldn't be that hard. Okay. But before doing the rest of that, let us go back and see what happens if I do this transformation and if I do this transformation. Okay, so in other words, because of this explanation that I told you here, instead of thinking it in this way, let us think in it in this way. So what will be the graph of f of minus x, and what will be the graph of f of x, say, plus 2 or plus a? Let me write plus 2 first. So you see here, I replaced x with minus x. Here, I replace x with x plus a, in that case, x plus 2. Now, my question is that what happens if I take my function and multiply everything by a minus sign, an overall minus sign? What will happen for the graph? And if I take the whole function and add 2 units overall to a constant 2 to the function, what will happen, do you think? Yes?
For the first one, it will be flipped around the x-axis.
It will be flipped around the x-axis, and for this one,
It will be moved up 2 units.
it goes up 2 units. So on the y direction, everything is natural, if I say call it natural. So if you add 2, what happens? Because what you are doing when you add 2 here, it means that your new y values are 2 units more than the previous y values. So what will be the effect? It means that whatever point you had, the y value of the point goes 2 units upward. Yes? Is that understandable? Yes or no? Yes? Are you happy? Okay. So if I take my function, so because you know that this y and that y are not the same, y equals to f of x plus 2, I am talking about a new function, y equals to f of x is another function. But the y values of this new function and the y values of the previous function are related like this. Whatever I had before, the new one is the before one plus 2 more. So it means that the y coordinates, the new y coordinates, are the old ones plus 2. So this means that every point goes 2 units upward. So if I want to summarize, you can understand this yourself as well. Okay, so if you want, we can test that here on GeoGebra. So what I do, I will take these off, okay? And then what I do, I will take this one and multiply it by minus sign. So what will happen? It becomes y is equal to, I put the overall minus sign and then open a pair of brackets and type my old function within. So it becomes this. And that is exactly what you see. And if you don't mind, let me change the color so that you can see better. So the color, for example, let us use it pink. Okay, so can you see that the pink one is the black one flipped, but about the x-axis, yes? So this part, which was already below, after being flipped, goes up. This part, after being flipped, becomes this part, and that part, after being flipped, becomes this part. Okay. And then, if you don't mind, let me also type that one, y is equal to x to the power of 2, and then I minus 2x. Let me add 2 units. And then you see that it goes upward. And if I change the color of this one, so let me choose that one, and then let me choose the color to be blue. So this blue one is the black one, but shifted 2 units upward. Is it 2 units, by the way? So why is that?
It goes from -1 to 1.
What? Ah, yes. The black one is starting from here. Yes, I was comparing. So it goes from here to here. So it went up 2 units. So if I want to summarize, let us summarize together. If I take x's out and put minus x, it will be flipped about the y-axis. If I take my function, put it in pair of brackets, multiply it by minus sign, it means that I'm multiplying everything by minus sign. It will be flipped about the x-axis. You need to remember that. And then let us understand the effect of this one. If I replace every appearance of x with x plus a constant, if that constant is positive, the shift will be to the left. And if the constant is negative, the shift will be to the right. But if I add something at the very end of my function, I have my function, I add something to it at the very end. If what I'm adding is positive, the shift would be along the y-axis upward, and if that's negative, the shift will be along the y-axis downwards. Yes? So that is the review. Okay, let me ask you a little bit tricky question. Let me see how do you understand that. We can combine these transformations one after the other, and that is the whole point. I want to take you here at some level, okay? But let us try to understand this. Let us assume that I give you this function. I give you the graph of this function, whatever it is. And I want you to understand the graph of this function. Okay, can you tell me which transformations I need to understand the graph of the new function? Do you understand what is going on? Yes? For example, let me try to see if you understand the algebra. For example, let me give you y equals to, let me write this as what function? X to the power of 3 plus 2x. What do I mean by f of 2 minus x plus 5? It means replace every appearance of x with 2 minus x, which becomes 2 minus x cubed, plus 2 minus x, yes? This is just this part, and then add 5 to it. So in other words, in this case, I am talking completely generic. I haven't given you f, I'm just talking in general. But let us say I give you this, and I ask you to draw the graph of this one. I have seen questions of this type in the national exam. They give you the graph of a function, and they ask you to draw the graph of the other function, yes? Without giving you the rule of the function. Yes? Yes, I just want to first digest the problem, what it means. Everyone is happy? Okay, now I want to tell me which kind of these transformations are supposed to be done one after the other so that I go from this function to that function. But be careful, okay? There is a point, I don't want you to spoil the point, okay? Yes, that is your chance. Okay, so first you, yeah.
You turn x to minus x first.
Yeah, okay, so you turn x to minus x. So what you're saying is that I start from this, you use this transformation x to minus x. So what do you think I will write here?
F minus x.
So no, everything, tell everything. Y is equal to f of minus x, okay. But have I reached to this one? Not yet.
No.
So I have to do some more transformation. You can continue.
You add 2 to the...
So what the transformation you are talking about? X goes to where?
You're adding a constant. So you're...
No, x to where?
2, x plus 2.
X plus 2. Okay. How many of you agrees with that one? Do you agree? Everyone agrees? No.
Yes.
Okay, I told you don't spoil the joy, but you did, okay? The joy is gone now, okay? That's not correct. X plus 2 is not the correct one because...
It's minus x plus 2.
No. I want to reach to this one. Yes, you have already done that for me. So you have already taken care of the minus sign. But you want to take care of this positive. So let us do this one. So what should I write in front? I want to test your understanding. What should I write? I have to replace every appearance of x with x plus 2. But what that means, it means this.
Oh.
Yes?
Wait, is it x minus 2 then?
So it becomes minus x minus 2,
Okay.
which is not what I want. So this transformation is not the correct one. So what is the correct one?
You have to subtract here.
So if I subtract, yes, and then if I subtract 2, this becomes this. Is that is the correct version? Yes, because if I multiply the minus sign, it becomes 2 minus x. And the next one will happen what? Add 5
Yeah, add 5.
to the end. That is not problematic. So it becomes 2 minus x plus 5, yes? So if I ask you, by the way, the name, the mathematical name for this is called reflection. So when you flip, the mathematical term for that flip is reflection operation. So you are reflecting about the y-axis, okay? And then you are shifting, or the more formal language, the formal one is translation. So you reflect first, and then translate. Translate means shifting, okay? But do you think I could do it the other way around? Yes. Can I start with shifting first and then reflecting? Okay, so let us just do that as well. So what we do, let us, another one, okay, another person. Can I do the other one? I want to insist to do the translation first, yes.
Then you first do x to x minus 2.
X to x minus 2, be careful, yes? Yes. X to minus 2, what happens? This becomes f of x minus 2, yes?
And then you do x to x minus x.
So that is again wrong. You didn't listen.
Because it's not, because now it's...
So I knew what to do, yes? I am doing this job for many years. So that is not correct. You understand why?
In this case,
Because when you shift x to, that's okay. But then you want to change x to minus x, but you are not allowed to change minus 2 to positive 2. You are only allowed to change x to minus x. So this becomes f of minus x minus 2, and hopefully you agree with me that this is not going anywhere. Yes? So this is not the correct one. So then you have to take it off, and then, okay, so what is the next one? So this is not good. So what should I do here?
You should have plus 2.
Plus 2 here. Okay? And then it goes plus 2, and then reflection. So it gives me what? F of minus x plus 2, which is exactly as 2 minus x. And then the next one is adding 5 units, yes? So it is important to do it. So let me write 2 minus x instead. So it doesn't matter really. It is up to your choice. But you have to have a wise way of doing things. So if you prefer to do the reflection first, your shift should be to the right, because you have to write x minus 2 after that. But if you prefer to shift first, then the shift should be to the left, and then do that. Yes? And then do the reflection. Is that clear? I don't know if there is a very good way that we can see it on GeoGebra. So do you mind if I make a simpler example? I think that will be complicated to power 3. So let me just stick to the same thing we had. Y equals to x to the power of 2 minus 2x. Okay? Okay. And then let us draw to find that function. Yes, I want to ask GeoGebra to draw this for me, but you know what to do. You need to replace every x with 2 minus x, and then add an overall constant 5 to it. Yes, so let us just do that. So I would type it again in GeoGebra. Y is equal to, instead of every x, I put 2 minus x, and then I raise it to power 2, and then minus 2 minus x, and then I will have plus 5 is that one. Okay, so yeah, was it right?
Yep, that was correct.
Okay, so let us see what happens. I cannot see it to be honest. Can you?
Yeah.
Is it the same effect we did?
Yep, it is.
But there is no. Yeah, there is a flipping around the y-axis. So I don't know if I just flip this one. So let me change the color here. Let me change the color here to say red. So, okay, now concentrate on the black one. Let us go to the first line. To the first line, we first flip and then shift. Yes? So, can you see that if I flip this about the x-axis, it will give me this function, y is equal to minus x, yes, to the power of 2, to the power of 2, and then minus 2 times minus x. So that was the function. So if you don't mind, let me change the color to, say, I don't know, yeah, this one. So this one is the flipping of the black one, and then
You're adding 2 units.
and then what we are doing, you see here, I flipped first, and then I have to shift two units to the right.
So you just
Yes,
go back.
can you see that? So if I shift these 2 units to the right, what will happen?
Just back
It becomes back to the same black one, and then I shift it 5 units upward, it becomes that red one. So that's correct, actually. Yes? Is that understandable? You can do it the other way around yourself. Okay, but be careful. That was an important point. So you might be able to, by the way, if you change the order of applying transformations, we say we commute them. Okay? So we're commuting these transformations. So we commute them together with each other. Okay, so that's it. So, but you see on the board, there are 2 operations that I haven't talked about, and I want to ask your feeling about it. So what do you think this will bring us? So what I do, I go to my original function, take every x out, and replace that x with 5x, with 7x, with a multiple of x, instead of adding 7, 5 to x. What do you think will happen and why? Don't destroy the joy, okay? Yeah. Because when you see the solution, then you can cook up something for it. Yes. This is how social science and politicians work, you know? They want to see what happened, then they start justifying it. Yes.
Can I change the slope of the graph?
Pardon?
The slope of the graph.
Okay, but in a very concrete way.
Well, yeah.
Yes. In a concrete way. I want you to understand that. So let us, by the way, I want you to see finally the people who are interested in understanding things. Because if you're not interested in understanding things, you can write the notes down and then memorize and use it, okay? But if you are that type of a person who wants to understand why, I want you to finally learn this trick, okay? So let us start with our friend y equals to x squared minus 2x. Now let me ask you one question. I replace x, let us say with 5x in this case. I want to explore what its consequences. So what does it mean? It means that I have a new function in which x is replaced by 5x everywhere. And I want to understand how the graph of these 2 different functions are connected. Okay, so how do you do that again? So again, I take a typical point alpha and beta. I pretend that this alpha and beta is on this graph, which means beta is equal to alpha squared minus 2 alpha. Okay, now I want to ask you one question. Can you cook up another point which is immediately guaranteed to be on the graph of this function using this? Here I don't want to go back and forth because I don't know what is going on, but my question is this. This is coming from putting alpha and beta in that equation. I assume this is to be true. My question is that can you give me a point using this in front of you and this in front of you, which guarantees that this point is on the graph of this function? Yes, Kim?
0, 0.
No. 0, 0 is, of course, this is because of this form of the function, yes. No, I'm just talking about this. I give you alpha and beta. Let us ask a question like this. What happens to alpha beta if I multiply the graph of this function by 5? Do you understand? So if you don't know the answer, you don't understand my question. My question is that you see an algebraic identity here, because I am assuming this point is there. Now, can you give me 2 expressions here so that it is immediately seen and guaranteed that this satisfies this equation? Yes?
Alpha minus 5. No, alpha divided by 5 and beta.
Beta. Yes? Because why? Alpha divided by 5 and beta. Do you agree that this one satisfies this equation?
Yeah.
Let us check. If I want to know if this satisfies in this equation or not, I need to replace y with beta, put question mark, and I have to replace x with what you proposed. Yes? And ask myself, is it true or false? But do you see immediately this is true? Because you actually neutralize the effect of multiplying by 5 by dividing by 5, then this 5 and that 5 are gone, alpha squared is left, minus 2 alpha is left, which is exactly what I know about. Yes? So what is happening now? So it means that the point alpha and beta is somehow going somewhere. Beta part is not affected, because you see the beta is the same, but the x-coordinate is divided by 5 now. I multiplied my x by 5, again working with x-axis is counterintuitive. I multiplied my x by 5, but it seems that the corresponding x-coordinates are not being multiplied by 5, but they are being divided by 5. Yes?
The graph is being compressed towards the y-axis. Like,
So along the x-axis.
Yeah.
Yes. Do you agree? Yes. Why? Because, for example, if alpha is 5, this alpha will go to 1. Yes. If alpha is 10, this alpha will go to 2. If alpha, I'm just making simple numbers so that I can calculate my 3. So alpha becomes 3. So what happens? So you see, it is not a shift. Because you might say, no, how do you know? It is a squeezing, might be it's also shifting, but this is not shifting, Because here, if I want to see this as a shift, the shift is minus 4 units. But if I shift this by minus 4 units, it becomes positive 6, not 2. So the effect is not shifting, this effect is squeezing. Yes, is that right? So the graph of this function will be the squeezed version of that one along the x-axis by a factor of 5. So that's also counterintuitive, because sometimes when you multiply something by 5, you expect that it becomes stretched. I don't know intuitively, but this is the other way around. So if you multiply by 5, it is being squeezed by a factor of 5. Okay, can you tell me how can I stretch it by a factor of 5? Divide by 5 or multiply by 1/5. Yes, that would be stretching. So remember that if I change x to kx, the effect will be a squeezing if k is greater than 1. It will be stretching if k is between 0 and 1. For 1, nothing happens. What happens if k is negative? It is not just a squeezing or a stretching. It is a squeezing, a stretching combined with reflection. Yes? Reflection with respect to the y, of course, axis. Okay, so you know that. So if I say, what is the effect of this application? Can you tell me what happens if I change x to minus 2x? The graph will be squeezed by a factor of 2 and then flipped around the y-axis. Or, if you want, you can flip around the y-axis first and then squeeze it by a factor of 2. Both of them are the same.
The second part of this with minus 2, it becomes minus 10x instead. Does that also affect the graph?
No, this 10 is 5 and 5 are cancelled. Yeah, that's the whole point. I want to go back to the same algebraic expression.
Yeah.
It's not hard, yes?
But, so the graph will look exactly the same except it's...
No, the graph, yes, that would be a squeeze.
Version.
So whatever happened for y coordinate,
Yeah.
it will happen for the y coordinate, but 5 times earlier.
Yeah.
Yeah, that's meaning squeezed. Okay, so is that understandable? Okay, and now the last question. What do you think will happen if I multiply the whole function by a constant? A constant k. So when I say, if I have a function f of x, so y is equal to f of x, and I multiply this by k, let us say k is positive, don't bother about negative ones, I get a new function. So don't think that y's are the same. Y equals to f of x is one function, y is equal to k times f of x is another function. So my question is that what do you think will happen? What will happen? Yes, Rasmus?
This time actually stretch up to y-axis.
Yes, because what happens when you multiply f of x by k, whatever y value you obtain is k times larger than the y value you had before. Is that right? So because you, exactly like the same thing, when I added k to it, when I say plus 2, every new y value is the old y value 2 units more. And here, when I say, if I multiply it by 2, it means every new y value is 2 times larger than the y value before, without affecting the x coordinates. So what happens? It will be stretched along the y direction, because x coordinates will not be affected, by the y coordinates will be 2 times larger. Yes? So this is a little, so this is natural, I would say. If you multiply by 2, the effect is a stretch. But if you want to squeeze it along the y direction, you multiply by 1/2, for example. But along the x-axis, this is the other way around. Is that right? Is that understandable? Okay. And now, I think we learned about all these things we wanted to learn. Let us see, what time is it? Yes, we are good. Now we want to go back to the problem in the book. None of them is discussed in the book. They have been discussed only for sine and cosine function for some strange reason. But this is completely generic, not just for sine and cosine function. Okay, so let me try to ask you a question. Let me see if you understand that. Hopefully you watched the video yesterday about the sine function. Okay, so let us try to understand this function. You already hopefully know the graph of the sine function. If you don't know, you can just simply draw it using GeoGebra right away. Now my question is that, what do you think will be the graph of this function? So let me put a 2 here. Let me work in degree, because I don't want to confuse you with radians. So 2 sine, and let me write here 3x, and let me write plus 30 degrees, and then let me write plus 5. Okay? So if you compare what I have written right away with what I have given you in the very beginning, so A is 2 in this problem, B is 3 in this problem, C is 30 degrees, and D is 5. Assuming that you have watched the previous video, you already know the graph of sine x. I want to ask you, what kind of transformations, forget about the graph, what should I do to this function with transformations that we discussed today to reach here? So let us just do it together. So I start from sine x. Okay, can you tell me what I will do first? There is no one single possible path you might commute. But let us just start with something, yes?
Multiply x by
3. I also agree with you. I like this one. Okay, so then what happens? This becomes what? Yes? Okay? But I already know what happens. What happens? The graph of this, whatever it is, it will be what? Squeezed along the x-axis by a factor of 3. Okay, just keep it in mind. Okay, what will I do next, do you think?
30 degrees.
30 degrees, is that right? Yes, because if you set x to x
Or you add
30
10
degrees,
10
yes.
10 degrees.
Yeah, because I want you to understand, some students still believe that the shift is 30 degrees. It is not.
We
No, you can do it the other way around. He started like this, I also like the method. Okay, by
Isn't
the way.
it nice if you start with x plus 30 and then go
Pardon? I don't want to dodge what I said, but I like his method. I don't know, for some reason it was more pedagogical. I can also listen from you later, okay? But I want you to understand, whatever you do, this is not the correct shift.
Yes.
Yes? After doing that. Because if I do this shift right away, I have to replace x with x plus 30, and when 3 is multiplied in it, I get 3x right, but I will get 90 instead.
Yeah.
That's not the correct shift. The correct shift is what? 10. Yes? So then it becomes what? Sine of 3x plus 30 degrees. Yes? Am I right? Okay, can you tell me, so from here to here, I squeezed above the along the x-axis by a factor of 3. Then what I got now, what I have it in my hand now, I shifted 10 degrees to the left because 10 is positive. And now I have the graph of this function, but I am not then here because I need this one and that one. So which one do you do first? Can you add 5 first and then multiply by 2?
No, then it's
No, because it will be 10. Okay? Yes, so what do you do first? Of course you can adjust it, I am not saying that, but I prefer to do it 3x plus 30. What is the effect of this one now? A stretch along the y direction by a factor of 2, because I'm multiplying the whole function by 2. And then finally, so let me write here 2 times. And then finally, plus 5, yes? So this becomes 2 sine 3x plus 30 degrees, and then plus 5. What is the effect of this one? It is a shift along the y direction, 5 units upward. Yes? So let us review. So we take the graph, squeeze it about the x-axis by a factor of 3, translate the new graph by 10 degrees to the left, and then stretch it along the y-axis by the factor of 2, and shift it 5 units upward. Then I will have this graph. Okay? So you see that by this transformation, I am not really affecting the main properties of my graph, yes? For example, if the original graph is oscillating up and down, do you agree with me? By none of these transformations, I am affecting those properties. I'm shifting, stretching, so this will remain the same. Okay, now Rasmus, if you want, we can go your way. You prefer it the other way. So you will start with this one. Okay, what do you prefer now?
Now we replace the first and the second.
What?
We add 10. We add 30. Place x with x plus 30 degrees.
30.
So we add 30 degrees to x.
Yes. So you say x to x plus 30. It becomes sine. It's good to do it in 2 different ways. Yes. And then?
We just multiply x by so replace x with 3x.
X goes to 3x. And then? The same things, yes? 2 and 5. Of course, let us do it the other way around. If I want to because when we are doing something, let us enjoy it, okay? So instead of adding 5, let me do the translation first, instead of rescaling. Then what should I do? 2.5, yes? So I have to do 2.5 first. Then it becomes what? Sine 3x plus 30 degrees plus 2.5. And then I multiply by 2. But when I multiply by 2, I don't have a choice to multiply it here, not there. I have to multiply everything by 2. So then what happens? It becomes sine 3x plus 30 degrees and then plus 5. Yes. 2, yes. Yes. So it's okay. So you see, when you flip, you have to expect that the translations are still, the operations are still the same. I have reflection, I have shifting, I have rescaling, I have translation again. I have the same set of transformations, but the transformations are not exactly identical. Because, for example, the shift was 10 degrees here, the shift should be 30 degrees if you want to commute, if you want to change the order of the transformations. This is expectable. I want you to know about that. Yes, please.
What kind of operations can affect the properties of the sine, like the oscillation?
Because if the famous ones are also probably rotation will do that.
Yeah.
Yeah, so the operations that are famous are reflection, translation, rotation. Yes, and rotation, of course, it's not a good idea because when you rotate the graph, it's no longer a function usually. Yes.
Could you draw these in GeoGebra?
Yes, I will. Okay, I will. But let us try to this GeoGebra. Okay, so here, so let us draw to. Do you want to do it step by step or only the final result?
Final result.
Okay, so do you remember? I don't know if you have seen the video. So let me adjust my axis to for degrees. So do you remember what we are supposed to do? If you have checked the video, I go here and check the graphics. Go to the x-axis and choose the degree sign here. So it is just symbolic. Be careful. Just it puts a circle on top. Okay, but then I choose the distance. For sine function, I don't know which one is good. Which one do you prefer?
One.
Might be 10 is good. So let us choose 10 here because we also have something for 10. Okay, so then it's not a good one, so I choose this one and I squeeze it a little bit so that I can see something in front of me. I can adjust it later. Okay, so let us put the final result here. So y is equal, and I think GeoGebra by default is in radian mode, so you have to use that symbol. So I write 2, and then I write 2 sine. Let me draw the first function itself so that we can compare. Okay, is that right?
No.
No. The reason is that this I told you it is by default on radian. So I go here and choose this degree sign as well, and then I will have another problem. By the way, this is correct, yes? Because sine should reach to maximum 1 when x is 90 degrees, and 90 degrees is far away. So let me just squeeze it a little bit so that we can see it beautifully. And then if you don't mind, let me also increase this one so we can see everything. Okay, I don't know if we can finally see that, but this is the standard sine function. But now let us type what you said here. So y is equal to 2 sine. Oops, what happened? Yeah, I really don't like this GeoGebra. Okay, so 2 sine, sine of 3x plus how many degrees? What was that? 30. So 30, I have to put the degree sign here as well.
You have to put it on the X or
I don't, yes, might be you are right. Doesn't hurt. Yes, and then a plus 5 there. Oops, what?
Yes.
It is up there. Yes, we don't see it because 5 units. Okay, so if you don't mind, let me move this down here a little bit, and then let us zoom out so something like this happens. So could you anticipate the oscillation will be faster?
Yeah.
Yes, because it is being a squeeze. So for example, in physics term, from of course that's also mathematical term we will study. From this one to here is 1 period, yes, and the function is repeating itself. So the period of the normal sine function is 360 degrees. But can you tell me? Okay, that's a good question because we need to know that. Can you tell me what will be the period of this function or that function? Because you are taking and squeezing by a factor of 3. So in the old period, now you can fit 3 periods. Do you understand? Yeah. So it means that if the original period was 360 degrees, what is the new period? 120. Okay, can you write a rule for it? By the way, whatever I am saying about the sine function, it's exactly the same as cosine. So let us not repeat that for that. So in general, if I want to write, let me write these details here, okay? So that is good, we discovered it together, so I didn't need to write a formula for it. So let me write these things. A is equal to A sine Bx plus C plus D, and Y is equal to A cosine Bx plus C plus D. Okay, the first thing we discovered, but T is the same as you'll see it in physics. T is the period. So the period of these two functions. Here you told me 120 degrees, but in general, what is the period? 2 pi over
over
E. Is that right? So the period becomes, if you're interested in writing in radian, yes, or you can write it as 360 degrees by b. But of course, I think in your book they are only talking about positive values, but now in principle you should have an absolute value here as well. Yes, because the period by definition is positive. Okay, another thing that I want you to know, could you anticipate the highest point of the graph? So here, the green one, if you see the GeoGebra, for the standard sine function, what is the highest height that the graph achieves?
1.
1. Okay, what is the lowest one?
Minus
-1. Could you, before seeing GeoGebra, the red one, could you anticipate the highest value is 7 and the lowest value is 3?
Yeah.
How?
Because you're doubling sine, so it should be, and then you're, so it should be twice.
Yeah, I want to find the maximum of this function. This is constant. I cannot tamper with that one. I cannot tamper with that one. This x is variable, so I can fine tune this to be maximum. If I want to gain maximum value for y, it is reasonable to maximize this part because there is nothing that I can do with constants. So what is the maximum of a sine function? Any sine function becomes 1. So the maximum value of y is what? In general, can you cook up something for me here? So here, I assume that a is positive, okay? So what is the maximum value?
Alpha plus d.
A plus d. Do you agree? Because the maximum value. What is the minimum value?
It should be a minus d.
No, minus a plus d.
Or minus d.
Because I want to minimize sine, the minimum of this is -1, so it becomes minus a plus d, yes? If a is positive. Okay, so if you want, I can take this one out. If a is positive. What do you think will happen if a is negative? So for example, let us say it's -2. What is the maximum again?
Minus
The maximum will be 7 again. Yes, if this is 2 and 5, the maximum is 7. If this is -2, what is the maximum again? The maximum is again 7, but it is achieved for something else. If this is 2, this becomes 7 if this part is 1. But if this is -2, the maximum is still 7, but it becomes 7 if this is -1. So it is achieved somewhere else, but the maximum value does not change. Okay? But should I modify the formula? Or do you think the formula is correct? No, I have to modify that, yes? This is for a positive. For a negative, y maximum will be minus a plus d. Y minimum will be a plus d. If a is negative, be careful. Okay?
You take the absolute value of a and then just.
Yes. I can write absolute value for plus d, and then that's it. Okay? So if you want to write it in one way, you can just write absolute value and minus absolute value.
Yeah.
Okay? But that is not my goal, because that is not that important. What matters is a and d. Okay? So let us calculate a and d from here. So how can I calculate? Let us add these two numbers. So y maximum plus y minimum is equal to a, and a are gone. It doesn't matter if I am working here or here. When I add them, a and minus a are gone. D plus d becomes 2d in both cases. So this d is equal to y maximum plus y minimum divided by 2. This is not in the book, but I want you to write it somewhere because you will need it. Okay? This is independent for any a, positive or negative. Yes? And then, if I subtract them, for example, let me take this one minus that one. This becomes a, minus a becomes 2a, but this decancels. So a becomes half of the subtraction. Okay, the reason that I'm telling you is that I will tell you why. Because the type of questions that you will get are these type of questions. First of all, do you have any questions regarding this? This is given in the book, but for some reason they haven't given this one. I think it's good to have it. Okay. Why I am asking you to remember these formulas? Because the type of questions that you might face, the hard ones, are the ones that the graph is given to you, and using the information on the graph, you are supposed to calculate A, B, C, and D. Okay? This is the type of questions we are more interested in. Okay, so this is very simple. This is also very simple. If you have the formula. And if you want to decide about A and D, you only need to know about Y maximum and Y minimum. And if you want to know about B, you need to know the period. The only problematic one is if you want to know C. C is related to the shift along the x-axis. But let me ask you the question. Is the shift here C units or not?
Minus.
Or minus? Is the shift the magnitude C or not?
No.
No, it is what?
We did it in the whole.
Yeah, so yeah, exactly. So this, you have to take B out first in your head.
So it's C minus.
It's C over B. So the shift is C over B. Don't get confused. So whatever you see here is not directly added to X. Shift about the along the x-axis is what is added to X itself. Another problem is, can you guess what is the problem again? In these kinds of functions that we have periodic behavior, C is not unique. Yes? So if I shift a little bit, for example, one period, I can take this one and put it on the other one. But if I also shift it a little bit bigger, I can move it more, but still I can overlap it with the graph. Do you understand what I mean? I said it very badly, but hopefully, because we are humans, we understand each other. Yes. You didn't understand me? So, okay, I have to explain a little bit better. Okay, so let us go back here. So what I'm trying to say, in the algebraic equations, the shift along the x-axis is unique usually. If you find one of them, unless there are some symmetries. But in the trigonometric functions, let me go back to GeoGebra and try to convince you what I mean. So if you don't mind, let me keep sine function as it is, and let me just delete this one and type cosine function here. Do you see why this happens? It's in radians, yes? So I need to switch that one to degree and then press enter. So let me put it here for you. And this is not a good rescaling, so if you don't mind, let me change the graphics. So here, let me make it a standard. I think might be 90 degrees is good, yes? And then closed. Okay. For example, let us assume that this green one is a rigid object. If I want to do the shift and put it on the blue curve, what can I do? I can shift the green one this amount. Do you see? Let me see if I can change this pen. So I can change this one to up to here. Do you agree? Then the green one will be exactly overlapping the blue one. But do you see that this is not the only possibility? Yes? I can decide to put this on this.
Yeah.
Yes? So I can make the shift from here to here. The effect will be the same. Usually for these kinds of functions, periodic functions, you don't have one unique answer for C. This is why in the exam, I might ask you, what is the smallest positive C? Or what is the biggest negative C? Do you understand what I mean? Because if I say, what is C? The answers are not unique, and might be all of them are correct. Is that clear? Is that clear from what I'm describing on the picture?
But in this case, it's C over B.
Yes, but in any case, the shift is not C. The shift is C over B in an appropriate direction.
So in this case, you have to switch it over 90 degrees.
No, but in this case, because B is 1.
Yeah.
If B is 1,
Yeah.
shift is C.
Makes sense.
So in this
But
case.
if B is not 1, then it's
Yes.
C over B is over
Yes. But let me ask you one question. Let us say that I gave you the green curve. Could you draw the cosine curve using the lesson today and the green curve? In other words, could you anticipate that the blue curve is just a shift of 90 degrees of the blue curve? How? Yes?
Because of their complementary. Or
Yes, so let me say. So you are saying that cosine x is equal to what?
90 minus sine x.
Okay, so sine,
X minus 90.
no, x minus 90 doesn't work. 90 minus x. 90 minus x. But the problem is that if you do this in this way, it is not just a shift, is it? It's a shift and reflection. Of course, it is correct. You can shift and reflect, you will see why. But if I want to do it simpler, let me just do it like this. Cosine x is equal to cosine minus x. Do you agree? They are the same. But cosine minus x is sine of x plus 90 degrees. Do you agree? Because now they are complement. So either you can write it like this, but then you need to have a shift because of negative x, reflection. But if I want to have it only translation, I can view it in that way. So it shows that the graph of cosine is the same as graph of sine. The only difference is that the graph of sine should be shifted 90 degrees to the left, because 90 is positive. And that's exactly what you can see. Do you agree with me? The blue curve is the shift of the green curve 90 degrees to the left. Yes? Any questions? Okay, I want to finalize this lesson by giving the type of questions that you might get in the national exam or in my exams, okay? And there are many of these type of questions in the book. I want you to learn how to do it better. So let me see if I have it with me, hopefully here. So this is the question I expect you to understand. So I give you a graph like this and with some information there. And then I am telling you this green graph that you see is the graph of a function of this type. For example, of this type or that type. I make it clear, okay? So in this case, let us concentrate on this one. I want you to fine-tune A, B, C, and D for me. Okay? So let me just repeat. I am telling you that this is the graph, is one portion of the graph of a function, of a sine function, the general sine function. And I want you to use the information given on the picture to find A, B, C, and D. I want to wait for you, because if you can solve the problem, that is what you really need. Okay, so if you don't mind, now let us do it together, okay? There are some 3 formulas. I don't think these two are in the formula sheet, but I'm sure about this is there. But let us calculate, you need to read y max and y min using actually using the information given on the graph. So can you tell me what is y maximum? What is y maximum? And what is y minimum? So let us go back here. So y maximum is how much? The highest point of my graph. What is that? Minus 1. Here is minus 1. How do I know it's minus 1? Because I have given you this is 1 unit. So every grid line on the y-axis is 1 unit. So this is the maximum one. So it's minus 1. And what's the minimum one? 1, 2, 3, 4, and 5. Yes. So y maximum is minus 1. Y minimum is minus 5. So then I can immediately calculate A. By the way, I forgot to give you the name of A. A is called amplitude if it is positive. I will write it later. But the amplitude here is y max plus y mean. Y max minus y mean divided by 2, which is minus 1 minus 5 divided by 2, which is how much? 2, yes? And D is y max, y min plus y min divided by 2, which is minus 1 plus minus 5 is what? Divided by 2 is minus 3. So this minus 3. Okay, now let us go back. Can you read the period for me from the information on the picture? Yes? What is that?
So it is 240 degrees or 240.
Yes. Why is that? Because this is this is what is called in wave theory. Do you remember? This is called a trough in wave, yes? And what is that one called? Crest, yes. So from one trough to the immediately next crest, it is not one period. It is what? Half a period. So, but this length can be read here. What is this one? You count the grids 1, 2, 3, 4, 5, and this is 100 degrees. So every grid line on the x-axis is 20 degrees. So this means that here is minus 20 degrees, and here is 100 degree. If I ask you what is the length that you see here is 120 degrees as the length. But that is not the period. This is half the period. So this means the period is how much? 240 degrees. But t is useful to get b. So I put the formula here. Yes? And then this absolute value of b becomes 360 degrees divided by 240 degrees. So what happens? It becomes 3/2. And if I take b positive, so let us consider that b is positive. You can also take it b negative if you want to, but then you have to also make life harder for yourself. So if I consider b positive, b is 3/2. Yes? Because if I take b negative, I am also bringing reflection in. Then I would recommend you to put everything in order so far. So y is equal to 2 sine 3/2 x in degrees, of course. Yeah, because that's in degrees. And then plus how much? Still we don't know c, but we know d. So the only thing that I need to do is to know how much shift is done. And I think I recommend you to draw the line y equals to draw the line y equals to d in your head. Because the effect of d is just replacing the x-axis to somewhere else. Yes? You are shifting the graph up and down. So let me show you what I mean. I myself prefer to do it like this. So what did I find for d? What did I find for d? d is minus 3. So in my graph, I draw by my pencil y equals to d, which is minus 3. What do I mean by that here? You see? So let me see if there is a pen feature here. Which one? Here. So let me change the color to red. Okay. So minus 1, minus 2, minus 3. So I draw this line in my head somehow. Yes? And I can pretend that this red line that I just drew is the x-axis. Okay? What I'm doing, I am neutralizing the effect of this shift. Okay? And then compare it here with the standard functions that I have. Because I want to have it as a sine function, I compare it with the standard sine function. Yes? So the standard sine function always starts from the origin. Something like that. But now it is starting from here. So this is the shift that I read. Is that correct? This is my way of doing it. I'm not forcing you to follow mine, but that's what you are doing. Okay? So I always, because you know cosine is a little bit different, even if they insist you to do it with cosine, I prefer to do it sine and then use my trigonometric knowledge to just change it with 90 degrees or something. But did you understand what I mean? So if I want you to do this, if this is one way of doing it, you can discover your own way. My way is to draw this with my pencil, y equals to d, and then pretend this is my new x-axis. And then to draw this, I have the standard sine function in my head. Yes, I don't care about the amplitude here, but I know that the standard sine function starts from the origin, but now it is starting from here. So that is the amount of shift. How much is that shift? 40 degrees, and that's to the right. So then I come back here. So I realize my shift is 40 degrees to the right. Okay? But what is the shift here? What is the shift in this equation? The shift, did you remember? It is not what? It is not C, it is C over B, but it is 40 degrees. I know that the shift is 40 degrees and it is supposed to be to the right, so this should be negative. So instead of 40, I put what? Minus 40. So C should be calculated after B, remember. And I already calculated B, so I put B there. So this becomes C over 3 over 2 is equal to minus 40 degrees. So C becomes what? Minus 80 degrees divided by C, yes? Am I right? No. 2 cancel, minus 60 degrees. This is at least one possible answer. If they haven't asked you, if they just ask you the answer is required, that's enough. Then that's up to me to check if the different answers are correct.
Then it's every oscillation.
Yes, but if I insist to give me the smallest positive C, what do you think you will do? That's a little bit problematic, yes? So what should I do?
The time period.
Yes. So that is what we can add multiples of the period. Yes? Because if you add the period to a function to x, it will not change anything, will it? No. So what we do, I start, by the way, be careful, I want to start adding x. Is the period correct? So what was the period here? The period was 240. So you mean that I add 240 directly to that, yes? It becomes 180 degrees. Let me see if that's correct. Can I do a smaller than that? No. No. You're right.
The next one is exactly that much.
Yes. Yes, because I want to go back to the same situation. Do you have anything else Rasmus to say?
Should we add 360 degrees?
The one period is 240.
But right now. Oh yes.
Every period is 240.
No, what you are saying is correct. You are thinking about adding 360 degrees to overall angle. By adding what Simon said to x, we will do the same thing, yes? So if I add, yes, because I'm talking about shift. So if I add 240 degrees to x, it means I am adding 360 degrees to the overall angle. So you are just talking the same thing from different perspectives. But if you are happy with it, if there is no obligation about positiveness or negativeness or whatever it is, you just keep this. But if you insist to give me the positive, the minimum positive C is equal to minus 60 degrees plus what? 240 degrees is 180 degrees. Yes? So 180 degrees is the smallest positive shift that I can do and make it right. Is that right? Okay, because there is no time, but it is good to double check these things using GeoGebra. You can test the last idea using GeoGebra to convince yourself. But this is the type of questions you should be very good at it. Finding A, B, D is very simple. And then after finding B, you can find C. If there is no obligation, that is the method that I told you. If there is an obligation, you find it and shift it appropriately to get the positive value. Yes?
Is that right?
Just wait a little bit. I have to close the camera. Yes?
If it goes to the right, then it becomes minus.
Yes. Yes.
Wait, is that really right? Wait, I'm sorry, because yes, if you add 240 into x directly,
Yes.
And when you expand, then you get 360. So you should add 360 to C, right? You should not add 240.
You want the value of
No, I want to see what shifts are possible.
Yeah.
So when I change x
you
to
didn't shift it by 240 now.
Because if you have to add 240 directly to x, now we're adding it to C directly. So if you replace x with x plus 240, and then you expand that, it becomes 3/2 times x.
Okay, so let me tell you here. So let me stop recording, but if this is wrong, I will fix it in the next video. So then if you want to go, you can go, okay? Now let us fix ourselves again. So what you are saying is right. If I add one period to x,
Yes.
it means that I am shifting the function one period,
Yes.
and it is guaranteed that I am not doing anything. Yes? But you are right, I think. Thank you for fixing it. So if I want to have x, but shift with 240 means x should be sent to what? X plus 240. But when I add this one here, it will be multiplied by a factor of 3/2, which gives me 360 degrees.
Yes.
And then 360 degrees will be added to this C,
Yes.
which makes it 300. Yes? So I think you are right, but let us check. So y becomes 2 sine, yes? So what we have to check, if they are really the same. Now you are right. But I don't need to be honest, I don't need to I don't even need to do this, because we know that sine of a box, whatever the box is,
Yeah, exactly.
is equal to the sine of the box plus 360 degrees. Yes? So now, if I write sine of, let us only consider this, 3/2 x minus 60, yes? This is equal to sine, but this is one thing that I want to make sure. So 3/2 x minus 60, this will play the role of my box.
Yeah.
Then I add 360 degree to it. This is guaranteed. But then if I simplify that, it becomes 3/2 x plus 300. Okay? And then if I compare it with that one, c is 300. But the question is that, can I make it less than 300? No. Yes. So thank you for fixing me. So yes, you are right. So the first positive c is 300. Yes? But you are right. It will be this but the shift is not 300.
No.
Yeah, I was also confused. Yes. Thank you very much for fixing me. Yeah, but I mean, to be honest, I really don't like this subject, but anyway. Yes.
There's a lot of.
I feel like you're making it a lot more complicated by saying that it's like of the form Bx+C instead of just saying that it's of the form B.
Yes, in British books, they write it in that way that you say. But because I want to follow the Swedish books, they write it in that way. You're right. In American and British books, I have seen that they write it like this. So they have a constant here, a, b, x minus c, and then d.
Okay, so the British and American books are actually more coherent than the Swedish.
No, but I prefer Swedish version.
I mean, it looks
prefer
nice.
the-
No, I prefer Swedish version not because of pedagogical point of view. My from pedagogical point of view is this, but do you agree this is odd way of writing the function? So I mean, I would never write sine x and then 2x minus 30 degrees so that the students understand what I mean.
Yeah.
Okay.
Because if you see a math box, it is completely natural to write 2x minus 60. So in this regard, I am with Swedish system now.
Well, from a visual point of view, I guess.
Yeah, but from a pedagogical point of view, they write it in this way that you don't get confused.
Yeah.
Yes. Well, so somehow it is good because I myself got confused. That is your fault, Simon. Okay. Any questions? Okay. Have a nice weekend. Thank you.